Okay, hi. So, you recall we have done the three practicals, the three titration, right? So now I'll explain how the O-level mark weightage would be, which is significant for you lah, because it's good to understand, why the marks is like that, where is it from and everything. So now we will know, Okay, so in O-level, what happens is, would this table be given to you? No. So in O-level, this table is what you need to memorize. So when people go into the lab, when they say you may begin, this is the first table they write down. Because you memorize the table, got marks on there. So let me explain how the mark weightage is like. So if you draw, so you start off by drawing your table. So first, your titration number. So 1, 2. Next one, it can be your final reading. Okay, honestly, if you want to write initial reading then final reading, it doesn't make a difference. The main problem here is you must write the word reading, because it is a reading that you read off the burette. If you write final volume, I guarantee you lose 1 mark. So the readings, these are readings because that's what you literally read and remember the units. After that, the difference will allow you to find out the volume of C used, and lastly, your best results. It is your best titration results. So if you recall, best titration result means plus minus 0.20 cm3. So in the O-level examination, the weightage is this. You exactly remember this table. Remember the table. You replicate, copy paste the table, 1 mark. So if you recall, 1 mark in practical exam is 0.5%. It's 0.5% of your entire O-level grade. Oh, memorize the table that is almost guaranteed to come out for every exam, give you 0.5%. Why not? Okay, what else? Next thing, if you recall, when you read the burette, the smallest reading is 0.1, right? Which means, what's the precision? If you remember, I said before, the precision of an object is half the smallest reading. So it's the smallest division. So half of 0.1 is 0.05. So the second mark is when you leave your answer in 2dp and the last digit is a 0 or 5. Means maybe 24.00 or 24.15. Cannot be 24.16 because you cannot see anything except half of the smallest division. So this gives you a second mark. That means you record your reading, everything, make sure there's 2dp lor. You make sure that happens, you get 0.5% of your O-level grade. So you memorize the table, you memorize the 2dp, 1%. Wow, you are 69% more to A. Yeah. Okay, what else? So you see, it's 5 marks. It is legit 5 marks. So these 2 marks so far, no technique one. Isn't it just procedural, memorize only one? Got technique meh? No technique. Then what's the third mark? The third mark is what you call 2 best results. Your answer can be 0.00, 0.00, 0.10, I don't care. As long as you have 2 best results, which is plus minus 0.20, you get the mark. That means you have 0 technique, you anyhow bomb, anyhow do, you get 2 best results, and the table, everything is exactly the same, you already get 1.5%. You get 3 out of 5. No technique needed. However, the last 2 marks of the 5 is technique. Accuracy itself is 2 marks. So, you see, you might be thinking, !aiya! Like that, I very smart, then I don't need to do titration at all lah, anyhow bomb my number. Technically, you can. But, you see, every time you practice, you want to do well because you don't want to waste these 2 marks. Because 2 marks is 1%. So, you do your best, and trust that your best is enough to get these 2 marks. So don't you worry whether it is that good, but you can always practice. So have that mindset that titration time, let's do my best, do it well. That's all. Then over time, your technique will improve, and after every titration, I will tell you when I go through the paper, I'll tell you the results. Then you realize that, I am starting to be able to get best results that is similar to teacher's answer. Means I'm reaching teacher standard. So I believe when you finally reach that, right, that you will definitely experience joy. You'll be like, whoa, I genius really, I high level, I'm pretty sure that will happen. So don't give up on the accuracy mark, but then again, don't worry about it. You do your best and trust that your best is sufficient. So let me explain a bit more what is this accuracy mark. So let me cook some values out, okay? Accuracy mark. I'm gonna give you some hypothetical situation, because it can go a few ways. So hypothetical situation is this. So let's say student A, your reading is 0.00, 21.00, 0.00, 21.00. So that means this person got 2 best results, right? So it's not just the best results. If you look at the question, you see part B. What does part B say? Average volume from your titration average volume. Another experiment, average volume again, you see, average volume. Then the last one, again, titration results, average volume. So this is a standard 1 mark giveaway. So it's not just, so accuracy is not just your results, it is the average of your best results. And because why? We are human. We will usually not be able to get 2 exactly same results. If you can, you are powerful lah. So in this case, let's say, okay, let me make it more realistic then. Okay, like this. Okay, this student is a human. Is human. So 21 and 21.110 means, yay, you get the accuracy mark. So for this student, your average volume of I don't know lah, E or D or whatever is actually just 21. Okay, let me exaggerate it further for you, shall we? 0.00. So first result, second result, third result. 29.00. Okay, that's a bit too much. 22.00. Then you realize, the second results are a bit off. So you think, why do I have best? Best results means those are the titration that you did well. Everything else is, there's some mistake lah. If there is a mistake, do you use the mistake reading to continue calculation? No, right? It's a mistake means, let's move on from our mistake. Let's learn from it. Isn't it? So in this case, best results is, average volume is your average of your best. So this is your average of your best. So your best counts. Your mistakes is fine. So in this case, you divide by 2, you get 21.05. So this one should also be 2 dp lah. Because why? You average of 2 dp, 2 dps, isn't it still 2 dp? So let's say this student A gets this. Then I tell you. So the teacher answer, answer is, okay, I give you example A. Answer is 21.10. If the answer is 21.10, how can I get that 2 mark? So if this is that, right, 2 marks means 20.90 to 21.30 is 2 marks. 20.80 to 20.89 or 21.31 to 21.40, 1 mark. What does it mean? Means plus minus 0.2, 2 marks Plus minus 0.3, 1 mark lah. That means you have a few buffer in that sense, you see. So in this case, this student A get how many marks? Student A will get 2 marks. Accuracy! Yay! So this is what I mean by accuracy. But honestly, in the lab context, exam, you do really, you worry whether you get your results is good enough. But then, is there anything you can do other than worry? No, right? Why bother? Why don't you just do your best and just calculate and focus on the other aspect that's in your control? Makes perfect sense, right? It's like you dwell on that 2 marks and will probably give up or waste your time and risk the remaining 38 marks. Don't make sense, what? So, actual exam, you do your get your 2 best results. Move on, don't worry about it. So, let's come back. So, this is what I mean by the 5 marks. That means 1.5% is free. Legit free. Yeah, so that is the idea here. So coming back, let's try the first experiment. I don't have the reading, honestly, but let's just work with a hypothetical value of 24. Oops. So let's say I show you Let's say the reading is 0.00 24.00 0.00 25.00 1.05. Let's say you use your own reading. I am just showing you the method. So if you realize, that means in titration, other than the accuracy mark, everything else, your answer will differ from my answer, which is fine because we are looking out for the technique. And in case you haven't realized, almost a lot for those questions, part A, part B, part C, part D, all 1 mark. So that means they actually help you, they break it down to very, very small parts. So it's a good thing, don't worry. So let's try. So the idea here is this. I show you exactly how to do the first one. Then after that, you will stop, you will pause the video and try the second one. Then you also try, then you can refer to the answer after that. The third one, I will not show you any answer. Alright, so that's the plan. Okay, first one. So this student did this, 24.00, 24.05. So these are best results, because best result is 0.20. Yay! So actually in O-level, if you have this, you have 2 best results, stop. Don't waste time and do already. Move on. After we finish everything else, you have spare time, okay, come back and try one more time. So, using this result, the average is actually just best result, the average. And I can tell you most of the time, you need to write this out and show me the working. That's the norm. So if you press your calculator will say this. Your calculator will say 24.025. Right, very nice number. But don't forget, this should be 2 dp. Because this is average of 2 dp. Average of 2 dp. Still 2 dp. In fact, I can tell you, in this whole question of titration, that's the only 2 dp you have. Everything else is the usual 3SF. So answer here is 24.03. Volume of solution B. Very simple. Isn't it here? This one legit giveaway mark. If I get this, I'll be like, yes, free mark. Okay, next one. Write a chemical equation. Alright, so we will be learning, we will learn this over this weekend. Remember I told you that with 3 videos, you'll be learning acid, bases and salt. So I'm giving us a sneak preview first. Okay, so in acid, bases and salts, you'll learn 5 reactions. With these 5 reactions, you can write an equation for a lot of things really. These 5 reactions are the skeleton of the O-level syllabus. a lot of the equation is these 5. So the first equation that we learn here is actually acid plus base give you a salt plus water. Acid, oh, isn't the acid just HCl? You are right. And if you recall, HCl is actually just H plus and Cl minus. So it is HCl. Yay. Next one, the base. Base, in this case, is your sodium hydroxide. Sodium hydroxide, sodium is Na plus, hydroxide is OH minus. You can refer to your periodic table. So NaOH, yay! Give you salt and water. Okay, my recommendation is this. You will struggle to figure out the salt. Why don't you write down what you know, which is water? So when you write down the water, all you need to do, okay, what is a salt? Salt, essentially is just a metal and non-metal. Essentially, it's just a cation and anion. So actually, you can see. You just see. You tell me lah. On the left hand side, what? On the left hand side has not appeared yet. It's missing. Surely you can see, right? You realize that, my Na plus missing. Hey, my Cl minus missing. Isn't that my metal and non-metal? Isn't that my cation and anion? Yes. So you do your cross method and you realize that it's just NaCl. Yay! Only after you are done writing them, then you balance. Balance is the last thing. And you realize that, it's balanced. 1 mark. Yay! So you can be assured that anytime we make you write an equation, is 1 mark in O-level. If I make you to write an equation with state symbol, that's 2 marks. Okay, next segment. The A concentration is this. Calculate. Okay, so don't panic. Look carefully. This is 2 marks. 2 marks is probably 2 steps. So don't worry. I know there's A and B. Wow, so complicated. Slowly. So let's try the numbers. So if you recall your hashtag hack, isn't a hashtag hack equation, which you have? Second set, change to mole. Let's change to mole. Yay! Mole of HCl, which is your A, 0.100. So mole equal concentration times volume. That's the formula in case you forget. So concentration times volume. Do I have the volume of A? Yes. This is your 24.03 over 1,000. So this one also need to take note. This thing is the trap. Volume should be in dm cube. Yep, so when you press the calculator, 4.03 divided by 1,000 times 0.1, 2.403 times 10 power minus 3. Cool. Then remember, third step is your mole ratio. So what we have now is HCl. They want me to find NaOH. So look at the ratio. 1 HCl is to 1 NaOH. Doesn't that just mean that it is the same? 1 is to 1, Exactly. So 1 HCl is to 1 NaOH. I don't have 1. I have 2.403 times 10 power minus 3. Which means this is 2.403 times 10 power minus 3. Cool. So don't think this is the answer. Just read. What you have is the mole. They want concentration. So that means concentration is mole over volume. So the concentration of your NaOH is the mole divided by the volume, which is 25 over 1000. Which is a final answer of 0.09612. Do you get the final answer? No. Remember 3SF. 961 mole per dm cube. 3SF. Yay! Oh, that's it. So that is how the calculation would be. Okay, so what happens now is you pause the video. Pause. Why you pause? Because you need to do your reading. You do so first and foremost, copy the table, this table into your practice tool. So you can pause the video now and copy the video, copy the table and try part B, fill in the table in part A, do part B, part C, part D, basically finish the entire practical tool. Then you can resume the video and I will show you the answer. So pause ready. Okay, paused. Okay, now you finish ready. You can now refer. So let's refer. So let's say same, my value here is 23 point, okay, these values are not the real value. You look at what is your own value. 23.15, 23.00, 0.00, 23.15, 23.00. Hey, still best result. Means you must remember to tick. If it is not a best result, don't need to cross. Only I cross. You just tick. Yay, good. Average volume, see, you read carefully. Show. How to show? Write down lor. So average volume of C, you add the best results and divide and find the average. .082 dp. So recall, this is a burette. Burette average is still 2 dp. But anything after that, guarantee is 3SF. Okay, next one. You can continue and calculate. So, okay, you are supposed to calculate the mole. Okay. So, let's see what do we have. We have volume, HCl. We have average volume. We have the concentration. Then try and calculate. Let's see what happens. Okay, so there's something interesting here. This is gram per dm cube. So you think, gram per dm cube, you times the dm cube. Do you think we can mole? No, right? Gram per dm cube times dm cube. Oops, okay, let me write it out for you. Gram per dm cube times dm cube. Oh, get your mass. So in this case, mass of HCl is 3.65 times 23.08 over 1000. 3.08, 3.65. You'll get 0.08424, which is 4SF. Then you can change to mole since they want mole, right? 0.08424 divided by 1 plus 35.5. 2.308 times 10 to the power minus 3, which is 2.31 over 3. 2.31 times down by minus 3 mole 3SF. Yay. Okay, next one, equation. So just now we did the equation already, right? But never mind, let's try again. Acid plus base, salt plus water, right? Acid HCl lor. Base NaOH. Water. Oops. So you can see for yourself, my Na never appear, my Cl never appear. So NaCl. Yay! Next one, done. Next one, now you can find the concentration. Okay. You see, they use the word hence. You know hence means you need to use the previous part, right? Then you use the previous part, use this to continue. Essentially. Mole ratio, yay! So mole, 1 HCl is to 1 NaOH, right? So if this is 2.308, okay, danger. Do not use rounded off numbers for next part. Use the original. If not, you end up with rounding error and lose 1 mark. 2.308 times 10 minus 3. Which means they are the same lah. Because 1:1. Oh yay, you have the mole of NaOH. They want concentration. We are almost there. So concentration of NaOH mole, which is 2.308, divided by volume. So let's take a look. What's the volume of NaOH, which is D? 25. Zero point 0.09232. Remember 3SF? 923 mole per dm cube. 3SF, yay! There you have it. Cool. Yay. Yep, that's it. There you have the answer. Oh, next one is an MCQ. Okay, I can guarantee you there's no MCQ in practical exam. This is just here to help you. So the reading is 20.4, 20.55, then 22. So what does it mean? If this is 22, it means more acid, right? More acid needed. Why more acid? Why do you need more acid? Because you got more alkali inside. I mean, it's only if your sample got more alkali, then you will need more acid to finish react, mah. Then let's take a look then. A, the burette. So okay, I color code for you. Burette. So burette is supposed to be titrated with Na. HCl is your burette. So you will fill in real life. You will fill your burette with HCl. So if you wash with HCl, correct what? That's a proper procedure. So nothing wrong, which means this is not the error. Pipette wash with tablet solution. In real life, also wash with whatever you're gonna. Remember, for pipette burette, you wash with distilled water, followed by whatever solution you're gonna fill it in. So A and B are true statement, but they don't explain why is it a mistake. They are correct. They are not mistakes. C. The student measure. Okay, honestly, remember your meniscus thing? So the difference is, let's say this is 23.10. This is usually 23.20. So actually the difference is not that significant one. So actually D is the better answer. Why? Why? So, okay, recall, your burette pipette is distilled water, then whatever you're going to wash it with, right? So imagine now, okay, this is your conical flask. Conical flask is tap water, then distilled water. So imagine you add in the tablet solution and you wash. Is it possible that some of the solution remains stuck? It's possible, right? And isn't this thing just alkali? So if you wash it with the tablet, some of the tablet thingy remain there, which means there's more alkali. That's why you need more acid. So that's how it is. Yep, that's about it. The third practice, I will not show you anything. You will do on your own. Yep, that's about it. Then after that, stapler, hand in. This is the first homework. Thank you very much. Any questions, please text me. Thank you. Bye-bye.